Isolating variables. You're probably the activity you will engage in most often in this class this year when you're doing work is isolating variables. Everything's an equation, and you have to learn how to move things around in an equation and solve for whatever the problem is asking you to solve for. So this is not a one and done. You're not going to take a quiz on this and never see it again. This is going to continue right up until June. So you need to know how to do this. When you solve problems for me, I make you isolate the variable before you put numbers in. That's part of the points for the problem. So learn how to do it, and you will be all set. So when we isolate variables, one of the strategies I guess you can look at is to do this order of operations in reverse. So order of operations tells you if you have some kind of calculation to do, some arithmetic, in what order you should do things. It tells you to solve what's in parentheses first and then take care of any exponents, then multiply and divide, then add or subtract. And when you're isolating a variable, just do that backwards. So the first thing you want to do with an equation when you're isolating a variable is add or subtract. It doesn't matter what you do first. And we'll go through examples of this. Then you want to look at what can you multiply or divide away. And then you want to look at your exponents and parentheses. So you're going to look at that last. Let's look at the first example. Delta x equals v times t, and this is an equation that you'll see very shortly, so we won't make the suspense last too long, but delta x is stuck together. So a delta is stuck to whatever comes after it in our physics equations here, and hopefully you remember that from chem a little bit. And this v with a bar over it is conveniently enough called v bar, and that just means an average. So yeah, the bar is stuck to the v, the delta, or that triangle there, is stuck to the x. And you want to solve this for t. So there's nothing to add or subtract, right? I'm doing my order of operations in reverse to isolate a variable. There's nothing to add or subtract away, but I can certainly divide that v away to get t by itself. V over v. What's v over v? Don't say v. Don't say 0. V over v is 1. So that's 1, and 1 times t is just t. Whatever I do to one side, I have to do to the other. If I didn't, then it wouldn't be equal anymore. So I'm going to end up with delta x over v bar, we would call that, equals t. And that is the answer there. Number 2, p equals w over t. And there are very few students who can solve a problem like this right off the bat when they show up in my room, sadly enough. But you want to solve this for t. So what's my first step? Well, t is in the denominator of a fraction. So I don't want to solve for 1 over t. I want to solve for t. So my first step is going to be to get that t out of the denominator. How am I going to do that? How do I undo dividing by t? I'm going to multiply by t. I'm going to write t over 1 so you don't get screwed up. And whatever I do to the right side, if I'm multiplying this by t or t over 1, I have to do it here too. I'm not going to write t over 1 here, but it's the same thing. T is the same as t over 1. Right? If you can see that this cancels out, that's fabulous. It does. And I get 1. T over t is 1. If you didn't quite catch that, you can see that when I multiply fractions, it's numerator times numerator, w times t, denominator times denominator, t times 1. And here we still get that t over t is 1. I'm left with just w on this side. So I end up with t times p equals w. I don't want to know w, I want to know t. So how do I get rid of multiplying by p? I divide by p. P over p is 1. Whatever I do to the right side, I do to the left side, and so I end up with t equals w over p. And that is my answer. So here you're told PE with a little subscript of a g equals mgh. And you would know by the time you encounter this equation, you'll know that PE with a subscript of g is all one thing. It travels around together. You can't break it apart. You can't divide a p out of it. It stands for potential energy, and you'll see that a little later on in the year. But it doesn't matter in this problem. I want to solve for h, and I can see h. There's no addition or subtraction, but h is being multiplied by m in g. And you know you have to divide those things out, hopefully. Now, do you divide them out one at a time? You can. You'd be making life harder for yourself, and there's really no need to do that. So we can divide them both out together, and that's what we'll do. I want to get h by itself. I can divide out mg together. mg over mg is 1. Whatever I do to this side, I do to this side. So I get h equals PE over mg, and that's my answer. Next one, hopefully you recognize. Area of a circle is pi r squared, and you want to solve for radius. So you know the area, and pi is a constant, and you want to solve for radius. How do you do that? Well, remember, we're doing the order of operations in reverse. So I want to do addition and subtraction. Well, there's none of that, but there is multiplication and division, and this tells me I have to do that before I deal with the exponent. So what do? I have a equals pi r squared. To get r by itself, first I'm just going to get r squared by itself, and I'm going to do that by dividing both sides by pi. Pi over pi is 1. Anything divided by itself is 1. So I get r squared equals a over pi. I don't want to know r squared. I want to know r. So what do I do to undo squaring something? I take the square root. Whatever I do to the left side, I have to do to the right side. Square root of r squared is r, and that would equal the square root of a over pi. Make sure you put that radical over the whole thing. Don't do this. That's wrong. This is an equation you should get used to seeing. You're going to be using it a lot when we get to this unit. So this is delta x. That delta is stuck to the x equals v with this little subscript. I probably should have even left it out, but that little zero is attached to the v. So delta x equals vt plus 1/2 at squared, and you're asked to solve for a. So again, what's the order in which we're going to do things here? It's going to be the opposite of the order of operations. First, I'm going to see, can I add or subtract anything away? I want this term by itself. Is there anything being added or subtracted here? And there is. Look at that. There's an addition sign. So for the first time so far, we can actually add or subtract things away. And so what am I going to get rid of? I'm going to get rid of this v naught t term. How do I get rid of it? I subtract it. It's being added to this. So to get rid of it, I subtract it. V naught t minus v naught t is 0, like 5 minus 5 is 0. Whatever I do to this side, I have to do to this side. So I end up with this. Delta x minus v naught t is 1/2 at squared. How do you get a by itself? Well, you can do it all in one step. We can divide by 1/2 t squared, and I can do that all in one step. 1/2 divided by 1/2 is 1. T squared over t squared is 1, and I'm just left with a, which is what I want. If I do that here, I have to do that on the left side too. And I would get a equals delta x minus v naught t over 1/2 t squared. And that's fine. You can leave it like that. That would make me happy. As long as when you plug the numbers in, you did it right. What else could I do, though? Let's go back here. What I could do is get rid of the fraction, and that's usually what you'll see me do when I'm solving these, is I don't like to have fractions in the denominator of fractions. So the first thing I would do is get rid of that 1/2. How can you get rid of 1/2? You can get rid of 1/2 by multiplying both sides by 2. I'm going to write 2 over 1, so you're not mixed up. 1/2 times 2 over 1 is 1. So this would end up going to 1, right? That would go away. But whatever I do to this side, I multiply this side by 2, I'd have to multiply this side by 2. And this is where I see mistakes pretty frequently, is that students will write this. And that is wrong, because you're multiplying this entire left side of the equation by 2. So you have to indicate that you're doing that. You can indicate that by putting parentheses around it. You can indicate that by distributing it, right? This and this are the same thing. Whatever makes you happy if you do it that way, but you can't just multiply it by the delta x. So now I have 2 delta x minus v, we would call that v naught, minus vt equals 1/2 at squared. I want to get rid of my t squared. I want a by itself. The whole point of this exercise. And so t squared over t squared is 1. So I would get a equals 2 delta x minus 2 v naught t over t squared. And remember, just because there's a t here and a t here doesn't mean you can get rid of one of the t's. You can't. There's no t here, so we're stuck with the t's we have. And we'll just have to make the best of it. So that is the answer for that one. Hopefully you recognize this too. This is the area of a triangle. You'll be using this equation too. And I want to solve for height. So once again, I have a fraction. Can you just divide both sides by 1/2 b and get h equals a over 1/2 b? Sure. So you can do this. And as long as you're keeping track of things, and as long as you write this clearly, this is fine with me. You can also get rid of that fraction. Instead of dividing by a half, what's the exact same thing as dividing by a half? It's multiplying by 2. So you could say a is 1/2 base times height. I could multiply both of these sides by 2. And I would get 2a, 2 times a half is 1, equals bh, divide both sides by b over b is 1, and you could get h equals 2a over b. This is exactly the same thing. If you made up numbers for a and b, you would get the exact same answer, whether you perform the calculation like this, you took half of the base and then divided it into area, or whether you doubled the area and then divided that by the base. Same thing.